In this tutorial, we will show how easy it is to generate pattern live loads using SAFE. By definition, pattern live loading is used to determine the most demanding sets of design forces by investigating the effects of live load placed in various critical layouts. In a model like this, that means applying the live loads to each bay and generating results for every possible permutation of loading. That is, adjacent bays, every other bay, every possible arrangement, all of which SAFE can do. SAFE offers two principal ways to create pattern live loads: Pattern Live and Pattern Live Auto. Pattern Live Auto works with the slab panels feature, whereby the defined slab panels are automatically loaded with the live load in a multi-step process within a single load case. This is typically the most efficient and fastest way to apply pattern loading, as the user typically only assigns one load and the slab panels are generated by the program. Pattern Live, on the other hand, requires that the user define the geometry of each loading, create a separate load case for each of the live load geometries, and then apply a load to each of the defined geometries. The analysis results are then combined using the range add feature. We will start by showing how pattern live loading can be done using slab panels and Pattern Live Auto. To the dead and live load patterns, we will add a pattern called Pattern Live Auto with a type of Pattern Live Auto. This will result in the program automatically creating pattern loading using the live load. Next, we will show how the slab panels used with the Pattern Live Auto can be added to the model. Slab panels are non-structural objects used to generate the geometric layout for the application of the live loads. Panels can also be used to report the maximum displacement in the panels. Slab panels may be generated automatically based on the layout of the grid lines or support lines, or drawn directly by the user. Here we will add slab panels using the grid option. If we apply the object shrink option, note that slab panels have been generated in all of the bays. Remember that slab panels are non-structural objects that are only used to help define the pattern loading. We will delete the extraneous panels where we do not have slabs. And we can redraw a panel when needed. If we select all, note that the taskbar reports 23 panels, one for each of the bays. We now select the slab by holding the Control key and left-clicking to get the selection form, and we select the floor as verified in the taskbar, and then go to the Assign Shell Loads Uniform command. And assign a live load of 50 pounds per square foot. This is the load that will be used in our pattern loading. Next, we will review the load cases. The program has created a load case for the pattern live loads with a type of linear multi-step static. This means that the results from the different regions defined by the slab panels will be combined internally in this single load case. To see how the program uses these load cases in design, go to the Load Combinations command and select dcon S3. We see that the pattern load case is used just like a live load. In this case, 1.2 dead plus 1.2 pattern live auto. Note that they are combined using linear addition. We can now run the analysis. With the analysis complete, we can view the deformed shape for our pattern live case. Note that as we skip through each step, we can see the effect of the loaded slab panels for all 23 panels. We can also view the forces. Here we look at the moments for range max and range min rather than an individual step. Because our load pattern type was auto pattern live, the live loads from each panel are applied using a multi-step process in a single load case. The results are combined such that the maximum negative or maximum positive response are never reduced. We call this type of combination a range add. The slab panels also provide a summary of their maximum displacements, providing a quick and efficient way to review the deformations in each bay. These can be viewed by going to the Display Show Tables command. And selecting the Analysis Result Enveloping Summaries table. For each slab panel, the max and min displacements are listed, as well as the cases that generated the displacements. Here, for slab panel 3, it is being reported that the maximum displacement in the up direction was generated by the pattern live load case, and the maximum down displacement was generated by a design load combination. The coordinates and plan of where the displacements occur is also provided. Now we will take a look at the steps necessary to create the same pattern loading if we use the pattern live option rather than pattern live auto in slab panels. Using pattern live tells the program that the user will define the load placement in each bay, and for every loaded bay we need to create a load pattern. 23 bays means 23 patterns, all with the type of pattern live. A check of the load cases shows that cases have been added for each of the live load patterns. Note that type is now linear static and not multi-step. This is because there is a separate load case for each loaded bay. With the previous examples, all of the pattern loads were part of a single load case. Now, when we go to the load combinations, a combination for the live load pattern has been created. This combo contains all of the live load pattern cases and combines them using the range add command, similar to what was done with the single load case in the previous example. This live load pattern combination is then used in the other design combos, similar to the previous example. Now we need to define geometry for the loads. That is, the layout of the loads. We do this by drawing a slab object with a property of none in each bay for a total of 23 objects. This will provide the areas to which we can assign loads. With all 23 slab objects added, we will select the first none slab object and assign a uniform load as part of PL1. We will again use 50 pounds per square foot. Select the second none slab object and assign a load of 50 pounds per square foot to the PL2 pattern. We repeat this process for all 23 slab objects, finishing with PL23. We can verify the loads by going to the display Show Load Assigns command. We can see how the loads move from bay to bay. Now we are ready to run this analysis. This time, when we step through, the analysis results are displayed for each of 23 load cases, rather than for the steps as determined by the slab panels of a single load case. And the moments are displayed using the range add combination case rather than a single load case. Although the results for the analysis approach using the pattern live type are virtually the same as obtained using slab panels and the pattern live auto type, the amount of user input is significantly more, and thus pattern live auto is usually the most efficient approach. As a last example in this tutorial, we will look at how to add slab panels using support lines rather than with grid lines. In this example, we have a simple model with irregularly spaced columns. If we were to generate slab panels using grid lines, we would end up with two rectangular panels, and our pattern loading would be based on those panels. Now let us say we wanted the slab panels to follow the general layout of the columns. We can do this by generating our panels based on support lines. First, we will delete the previously added slab panels. Next, we go to the Draw Support Lines command. Support lines give a general idea of the lines of support in the slab and can be used to lay out slab panels and design strips. We will add the support lines along the X grid on layer A. And the Y grid on layer B. Next, we will select the support lines on both layers. And then go to the Add Edit Slab Panels, Add Slab Panels using Selected Support Lines command, rather than the grids. When we shrink the objects, we see that the edge of the slab panels follows the layout of the columns. We can select the slab and assign a live load to it. Again, because we are going to use the pattern live auto option, we only need to assign one load to the entire slab, and the pattern permutations will be handled by the program. Going to the load patterns, we define a new pattern with the type of pattern live auto. Once again, the load cases form shows that our pattern case is a multi-step static. We can now run the analysis. Now, when we look at the deformed shape for the pattern live loading, we can see how the loading is arranged according to the layout of the slab panels and support lines. In conclusion, the pattern live auto option, regardless of how the slab panels are generated, that is, by grids, support lines, or drawn directly by the user, automatically steps through all the permutations of live loading, whereas the pattern live option can generate much the same results, but with typically more user input. This concludes this tutorial on pattern live loading and the use of slab panels.